Okay. Assalamualaikum and good morning and welcome to Dynamics ECS 429. It's 28 October 2021 and it's already 11:20 a.m. So we will start our class. So for today's class, we are going to learn we're still in uh topic 1, which is curvilinear motion. Okay, we're still in topic 1, curvilinear motion, which is still on kinematics. Kinematics of particles. Okay, we're still in topic 1. So basically, for curvilinear motion, there are two types. Okay, one is called the rectangular coordinate system, and the other one is called the non-rectangular coordinate system. Okay. Do you remember what we learned last week?
Yes.
Not last week. Monday. On Monday, we learned a rectangular coordinate system, right? And
Yes.
we saw problems related to what? Motion of projectile, if you remember. It involves what? Free flight motion, remember?
Yes.
Okay. And
Yes, yes.
then, good. And then, what do you remember? You have to resolve the components into the horizontal and vertical components, right? So you resolve the motion. You resolve what? The motion into horizontal,
And vertical.
yeah, and vertical components. Using what? The one that has the constant, constant what?
Acceleration.
Yeah, constant acceleration formula. Okay, all right. Okay, next is the non-rectangular coordinate system. Okay, for the non-rectangular coordinate system, there are also two types. Okay, there are also two types, which is the normal and tangential. Do you remember I told you about this last week?
Yes.
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 And the other one is what?
Radial and transverse.
Radial.
Yes. So radial and transverse. So for today's class, we're going to focus for normal and tangential. So normal, the symbol is usually N, and the tangential is usually the symbol T. So for today's class, we're going to focus this. And then for next week, we're going to do radial and transverse. Okay, so for today's class is normal and tangential. Okay. Right. Normal and tangential. So what it means is normal and tangential and radial and transverse are the non-rectangular coordinate system. Okay, all right. It's still moving along a curved path, but now it's different. Okay, all right. So let's say we have a particle moving along a curved path like this. Okay, let's say this is the yeah.
Sorry, madam, dah share screen eh?
Oh my God,
Sorry,
you
madam.
lah. It means I have been talking to you and you have not been seeing my screen, eh?
Uh-uh.
Masya Allah. Okay, alright, never mind. Tapi you mengangguk tu you faham lah.
Faham.
Okay. Okay, jangan macam apa dia cakap ni, nothing goes in mind, tu lagi teruk Okay, so, okay, now, if you look back here, can you see kinematics of particle, curvilinear
Yes.
motion? There are two types. One is the rectangular coordinate system, the other one is the non-rectangular coordinate system. So for the rectangular coordinate system, we have studied the motion of a projectile, free flight motion, and you understand the motion. You need to divide it into components, one horizontal and vertical components, but you use the constant acceleration formula. That one you understand, yeah? So for the non-rectangular coordinate system, there are two types. One is the normal and one is the normal and tangential, and the other one is radial and transverse. These are what you call methods. Right. So for today's class, we're going to learn about normal and tangential. Okay. Can you see now?
Yes.
Okay. So let's say you have a particle moving along a curved path. So this is your curved path, and this is your origin. Sorry, not position, origin. So this is your origin. So the particle is moving along a curved path. So let's say this is the curved path it is moving. This is the particle, okay? So of course the particle can be anything like an aeroplane, a car, a box, whatever lah. Okay. So for first what you need to do is you need to identify where is the normal axis and where is the tangential axis. So when the tangent is usually the tangential is tangent to the path. So let's say this is uh, the the curve of the particle. No, the particles is moving along a curve. The tangential must be tangent to the path. So this is how you draw tangent lah to the path, tangential. Okay, and then the normal must be perpendicular to the tangent. So this must be the normal. Okay. All right. So you have to be able to identify the tangent of the path and the normal of the path. Okay. Now let's draw more particles moving along a curved path and see whether you can draw it. Okay. Let's say we have another line like this. So there's a particle here. There's a particle here. Okay. All right. So how do you draw the tangent? Can you draw? So this is how you draw the tangent. Let's say the direction is starting from here, the direction of the velocity of the particle, the direction. So this is how you draw the tangent of the path. Okay. Can you draw that? The tangent? Okay, easy, eh? That's how you draw the tangent of the path. Now, to identify the direction of the normal is actually very easy. First, you need to draw the shape. Okay, so since the particle is here, so the shape, you draw a circle shape of how each particle will look like. The circle shape, the concave. So can you see me drawing the circle shape?
Yes.
Okay.
Yes.
So to identify the normal of the path, it must be at the center of the circle shape. So this must be the normal. Okay. Understand? So if I draw this is the basic one. Let's say I draw a different type of line. Uh, let's say this one. So what is the tangent? The tangent will be like this, and the normal will be like that. Okay. Do I make sense? Do you understand?
Yes.
Okay. So when you get a question that is a particle moving in a circular motion, then you understand that you need to use normal and tangential like this lah. Okay. All right. So okay. So what is the important formulas that you need to know? Okay. All right. So first you have identified the tangent and the normal, right? Okay. Right. Let me draw another diagram below here. Okay. Don't worry. Listen first. Okay. So let's say this is the direction. Okay. We have a particle. So you know already that the tangent is moving here. the normal is moving here. So the tangent, this is your AT and this is your AN. And to find the acceleration, it will be like that, A. So let's say we have another one. Yeah. So this will be the tangent. This one will be the normal. And this is the acceleration. You understand? Can you draw that? You understand how to draw that? Boleh? Faham tak?
Boleh.
Okay. All right. Now, what is AT and what is AN? Okay. So what is AT? Okay. So what is AT? AT is the change in magnitude of the velocity. So AT is change in magnitude of velocity. So when change of magnitude of velocity, it means the formula for AT will be dv over dt. Sebab dia change in magnitude. Now, what is AN pula? Okay. AN pula is change in direction of velocity. So the formula for AN pula, change in direction of velocity, is the velocity squared divided by rho. And what is rho? Rho is the radius. Okay, so if this is your circular motion, if this is your circle, so radius is rho. So this will be your rho lah, the distance from here to here. Let's say this is your center. So this will be rho. Ni will be rho. Maksudnya panjang dia lah. Understand? Okay. So AN is change of direction of velocity. So the formula ada involve rho. So AN equals to V squared over rho. AT pula adalah change in magnitude of velocity and the formula is dV over dt. And lastly, what is the formula for acceleration? So acceleration will be what? Square root of AT squared plus AN squared. So that is the formula. So there are three formulas here. AT, AN, and then acceleration. Okay, all right, those are two important things. Okay, and then if the question is related with constant acceleration, if if dia punya AT, if dia punya AT is constant acceleration, maksudnya you punya AT ni is ada constant acceleration, it means you have to use the basic kinematic equation with constant acceleration. And you remember what is the formula? V equals to V naught plus ACT ACT lagi. Ingat tak?
S equals to S naught plus V naught T.
Okay, tapi kita punya AT ni dah jadi constant lah. It depends on the question, okay? Let me just write the equation properly here for you, okay? Okay. C, yeah. E, and then last one. Dia tak ada roti sana? Koyak-koyak dah? Bagi tadi. Okay, alright. Okay. You also can have this one if it's constant acceleration, This one you remember, Don't worry, it's not difficult. You akan understand it clearly when we do example. Okay, you can also have acceleration that is not constant. So when it's not constant, kita punya AT jadi apa? dv over dt lah. Betul tak?
Yes.
Ah,
Betul je.
and then you know there are also other formulas involved, right? V equals to ds over dt, and then
ADS.
ADS equals to
VDD.
DVD. Okay, so
Oh.
those are the important formulas. And then sometimes in the question, they don't give you the radius, rho. So if they don't give you the radius, the formula for rho is, let me write the formula for rho, equals to 1 plus dy over dx squared 3 over 2 divided by d squared y dx squared. Okay, all right. And then you understand, just now, very clear. AT equals to what? V dot. Do you understand what V dot means? You remember V dot, V double dot? Ingat?
Tak.
Hah? Ingat tak?
Double
Apa
dot.
tu V dot, V double dot? Apa maksudnya?
Differentiate.
Ah, ya. Okay.
Uh,
Kalau
habis.
double dot, differentiate 2 kali. Ingat tak? Okay. Patutnya ada masa statik kan?
Tak sure lah pula. Ada?
Ada. Same same meaning Okay. Alright. Okay, so these are the important formulas that you need to remember. So maybe we can try to do a question, but before that, let's try to understand what is an example that is related to normal and tangential. Okay, remember when you study the free flight motion? Remember? Free flight motion, the example is what? It must be a particle yang yang fly due to free flight yang ada gravity, betul tak?
Yes.
Okay. This one was when you study the rectangular coordinate system. Okay? But now we're doing what? The non-rectangular one. So when in the non-rectangular one, for normal and tangential, okay, let me just buat simple lah, normal and tangential. What are the examples? Example that I can give you is like when you go to the playground. Let's say you go to the playground, there is what? A swing. Let's say you are on the swing. Okay. This is you. Okay. With your ponytail. Okay. Okay. Let's say this is you. Okay. Okay, tak cantik sangat lah. So let's say you need to draw the normal and tangential. Do you think you know how to draw it? The normal, the tangential is the direction, is the tangent of the velocity, tangent to the path. So the velocity is, let's say, is going up like that. So this is tangent. And how would the normal be? This will be the normal. Understand? So, and then this girl is swinging, right? Dia swing macam mana? Macam ni. Betul tak?
Yes.
So another easy example is, let's say you have a necklace, a necklace or pendulum, for example, and then it's swinging like that. Okay, dia swing macam tu. Betul tak? Dia swing macam ni and then dia patah balik. This is also an example for normal and tangential. So the tangent will be what? The tangent will be like that. And this one will be the direction of the normal, and then this will be the acceleration. Ni akan jadi the acceleration, okay? And then another example that is easy that you can relate to is, let's say you are driving around a circle of a roundabout. You know roundabout? roundabout section 2 contohnya. Kan ada roundabout tu. So this is your car lah. Ni car. Going round the roundabout. So this is tangent to the path. And then dia adalah normal. Ni tangent dia. Ni adalah normal dia. Faham tak? Another good example is macam ni lah. These are the types of examples lah. So you read the question carefully and then you identify kalau dia melibatkan free flight motion, you have to solve using the rectangular coordinate system. Tapi if it's not free flight motion, you can resolve it using the non-rectangular components and then you can identify the normal and tangential part lah. Kalau rectangular, you kena buat apa? You kena resolve it X to Y kan? Betul tak? Okay, boleh tak? Boleh kot kan? Mungkin kita
Boleh.
cuba soalan. Kita try to do some questions related to this and see whether your understanding is fine. Boleh?
Madam, saya nak tanya something ya. Saya nak tanya apa beza free flight motion dengan free fall motion Dia ada distance
Free flight tu maksudnya macam dia terbang macam tu lah. Dia terbang kalau ni dari pandangan 2D dia terbang macam ni lah. Particle ni dia move in the curvilinear macam ni lah. Dia terbang dalam keadaan a curve line macam ni lah. So that's why kita kata free flight. So kadang-kadang aeroplane lah, bola lah yang in a curve line macam tu lah. Kalau free fall motion, dia macam let's say ni tangan you. 1, 2, 3, 4, 5 jari. Kan? And then you ambil bola, dia jatuh straight ke bawah. Oops. Free fall motion in a straight line. Kan? Dia jatuh terus ke bawah, straight line. Macam ni, macam yang free flight motion ni, dia ada initial velocity. Dia ada V0. Faham tak?
Okay.
Okay. Ni you macam lepaskan dia.
Sebab saya teringat macam yang
juga. Dia
first
sama
class
juga.
yang
Dia sama juga. Dia fall due to gravity. Tapi yang ni straight line, yang ni curve. Okay.
Bukan sebab saya teringat yang ada yang macam first class kan yang macam
Betul.
apa? Dia paling bola ke atas and next position dia jatuh.
Sama je, you still kena guna formula constant acceleration. Dua-dua ni kena pakai formula constant acceleration. Tapi cuma bezanya constant acceleration yang ni yang basic tu lah. Yang V equals to V0 plus ACT. Yang ni pun sama. V equals to V0 plus ACT. V equals to V0 plus ACT. Cuma you
Semua
kena...
dia ada projectile.
Cuma you kena you kena guna satu vertical motion.
Horizontal.
Satu horizontal. Tapi yang ni, yang bola ni yang kita lepaskan tu atau kita baling ke atas dalam straight, kita tak perlu nak resolve it to vertical atau horizontal. Okay. Alright. Okay, so now kita nak focus on example related to normal and tangential. Okay, alright. Maybe you can copy this question, boleh? Because nanti later on you all kena buat project. Tapi your project will be topic chapter 3, 4, 5. So you kena cari satu example yang related to real life. Tapi it must use topic related to chapter 3, 4, 5. Macam ni chapter 1 kan? Tapi tak apa, project tu nanti kita explain kemudian. Dia lebih kepada poster presentation but not now lah. Okay, now let's try to do this question. Okay. Can you copy?
Okay, madam.
Azan cuba suap Ahmad roti sana.
Dia dah makan dah.
Okay, good. Okay, have you copied? Okay, tell me when you finish copying this question.
Okay, madam.
Dah.
Dah?
Dah, Mida.
Dah? Okay, dah. Okay. A motorist. Okay, kita try to do this question together. A motorist is traveling or a curved section of the highway with a radius of 750 meter. Okay, now. So let's say this is sebab dia dah bagi tahu dah ada curve dia, radius dia adalah 750 meter. Dia pun 750 meter lah. Okay, so this is our rule lah. Okay, 750 meter. Okay, now at a speed of 90 kilometer per hour. So let's say the speed of this vehicle, let's say now I'm drawing the vehicle. So let's say this vehicle is green color. Okay, this vehicle is green color. So its speed is 90 kilometer per hour lah. Let's say its speed is 90 kilometer per hour lah. The motorist suddenly applies the brakes. Okay, so what happens when you apply a brake? Dia decelerate lah, macam nyah pecut lah, causing the automobile to slow down at a constant rate lah. So maybe asal dia 90 kilometer per hour lah. But then after that, what happens to it? It starts reducing dia punya speed. Dia become 72 kilometer per hour lah. So asalnya maksudnya the initial say the initial speed is 90 kilometer per hour, and then after that the final speed dia jadi if you read here, starts to slow down at a constant rate, knowing that after 8 seconds, the speed becomes 72. Okay, so later it becomes 72. So what do you think? First dia moving ke depan. Bila dia reduce dia moving ke belakang, betul tak? Do you understand? Sebab dia tekan brake.
Yes.
So dia reduce, dia moving 72 kilometer per hour lah. Okay, now so let's say kita identify dia punya direction dululah. Okay, ini dia punya T, and then of course tangent to the path lah. Ni the speed dia tangent to the path Yang I lukis tu lah kan. And then dia punya normal macam ni. Betul tak? Okay, so this is tangent to the path, this is the normal. Okay. Okay. Alright. Okay, now. Okay. Now, try to read the question. What is it asking you to find? Determine the?
Acceleration
Yes.
after the brake applied.
Okay, so tapi immediately after the brakes have been applied. Okay, immediately after the brakes have been applied. So the acceleration will be the square root of 80 squared plus.
AN squared.
Yes. So now you have to find 80, and then you also have to find AN. So what is 80? The formula for 80? dV over dt, right? Okay, now if 80 equals to dV over dt, what is a dV? Now, right now, your your initial is 90 kilometer per hour, and then it becomes 72 kilometer per hour. Okay, so first of all, you have to change the units. 90 kilometer per hour, you must change to meter per second. So how do you change the unit? What do you do? 90 multiplied by 1000 divided by 3600 seconds. Okay, so 90 kilometer per hour, you must multiply by 1000 meter, which is 1 kilometer, and then 1 hour berapa second? 3600
360.
second. So when you do this, what would you get? Your
25.
left. Yes. So the answer is 25 meter per second. And then for 72 kilometer per hour, if you change the units, what do you get?
Twenty.
Okay, 20 meter per second. So when you want to find 80, do you remember what is 80? 80 is the change in magnitude of velocity. So when you want to write, so 80 is the change in magnitude of velocity. So when you want to find 80, so what is the change of magnitude of velocity? So usually what do we do? Do we the final minus the initial, or the initial minus the final? Class, what I'm trying to say, 20 minus 25 or 25 minus 20?
Hmm.
20
Final minus initial.
minus 25.
So 20 initial, final minus the initial 25 divided by the time. And what does it say? The time taken? 8 seconds, yeah? So what is the answer? 20 meter per second minus 25 meter per second divided by the time taken. What is the answer?
Negative 0.63.
That is 0.625, eh?
25.
Okay. Now, so here you can see that your 80 is negative. So what we can say is, so let's say this is our car again. So our 80 is negative. So the direction for 80 is the other way. And the normal is AN still the same. So what would our A be? This is our A. Okay? All right. Now we need to find AN. So what is AN? V squared over rho. And what is the definition of AN again? AN is the change in direction of the velocity. So now for velocity for AN, which one do you want to choose? Do you want to choose the 25 meter per second or 20 meter per second? But you know rho is already 750 meter, the radius. So but velocity, this one, which one do you want to choose? Have a look at the question. He says here immediately after the brakes have been applied. So if you want to find the acceleration immediately after the brakes have been applied, so you need to choose the velocity to be, because immediately after the brakes have been
Final.
25, immediately after the brakes have been applied, the speed is still 25. So it means 25 squared divided by 750. So 25 squared divided by 750 dapat berapa? 0.833. Sama tak? Meter per second square. Oh, jangan lupa ni ada second square. So in the end, if they ask you to find the acceleration, how do you find the acceleration? AN squared plus AT squared. Can you please tell me what is the acceleration?
One 1.041.
Yeah. So action 041 meter per second square. So that is the answer. Okay, good. All right, don't worry. There are a lot of questions in the tutorial that you can try to do that is related to this topic, and then when you try, you can figure out how to you understand better how to solve it. Okay, now I will give you one question for you to try. However, this question is a little bit challenging, but you can try, and then what we will do is I will give you the answer and then we can discuss in last class. So for the previous question, motion of projectile that I gave you, were you able to get the answer?
Yes.
So good. So as long you're doing it, you're keeping track what I give you, then you should be fine. Okay. So let me give you another question, but I will give you the final answer only, but you have to try to do it. And if you unable to solve it, we can discuss. Boleh? Okay.
Boleh.
Boleh. Okay.
Okay.
Okay, just copy, yeah. Alright. Yep. Okay. Okay. Kita nak besar kecil pula. Never mind lah. Okay. Tak cantik pula writing. Oh, sekejap Macam tu pula dia. Sekejap okay, nampak sikit. Okay. Boleh? Can you copy this? I know it's already 12 o'clock. Just copy this a bit. The boxes travel along the industrial conveyor. Do you know what is an industrial conveyor? Pernah dengar tak apa tu industrial conveyor? Kalau pergi bercuti mesti nampak. Tahu tak industrial conveyor tu apa? Kalau you pergi holiday, naik flight. Apa tu?
Yang roll baggage tu.
Yes. Okay, so the boxes travel along the industrial conveyor. If a box starts from rest at A and increases its speed, where t is in second, determine the magnitude of its acceleration when it arrives at point B. Okay, now you need to draw the diagram. Okay, so let's say ni bentuk conveyor belt tu. Conveyor, industrial conveyor tu. Okay, so let's say this is your box and this is point A, and then your box reaches here and this is point B lah. Okay, and then the direction is going this way lah. So this will be your T lah. Betul tak? Your tangent for block B, and then your normal will be ni lah. This will be your normal lah. N lah. Okay. Alright. Let's say I give you the radius point here 2 meter. Okay. And then let's say panjang sini sampai sini 3 meter. Alamak, tak proportionate pula 3 meter dengan 2 meter ni. Nanti make sure lukis ni lebih panjang 3 meter tu. Okay. Alright. So the box is travelling. Okay. So you dah identify N apa, T apa. Okay. So now for this question, dia minta also again the acceleration kan. So again very simple. Determine the acceleration. It means you kena cari square root of an squared plus at squared lah. Tapi the difference is for an you need to find what? For point B. What is an for point B? And what is at? Kan? But for point B. So if you remember an, apa formula dia? V squared over rho. Apa formula at? You tahu. So what is the velocity that you have to find here? Is you need to find the velocity of B. So tu triknya lah. And then the thing is, right now you have the acceleration, you have 80. Tapi you punya 80 dalam sebutan apa? T. Nampak tak? 80 you. 80 dia bagi tapi dalam sebutan T. Meter per second square. So kalau you nak dapatkan magnitude 80, you kenalah solve T, betul tak? Yes? You understand? So you need to solve T.
Yeah.
Tapi again, macam mana you nak cari velocity? So remember apa yang kita belajar sebelum ni? Position, velocity, and then
Acceleration.
acceleration. From position to velocity, you need to differentiate. Yes. And then from here, you need to integrate. Okay. Okay, I don't want to give too much information. Why don't you try? But I will give you the final answer. Okay, so the answer is 5.36 meter per second square. Okay, this is the answer of the acceleration B. Okay, this one. Don't worry, cuba if you cannot get the answer, we can discuss in our next week class lah. And then next week kita akan do radial and transverse. Boleh?
Madam,
Okay.
saya nak tanya yang soalan example sebelum ni kan, yang dia nak cari velocity tu, kenapa dia guna 25 ya?
Okay, mana benda tu lah? Mana page yang lain-lain ni? Hilang dah.
Kat kiri, madam.
Dia kena buat apa? Hilang dah. Alamak, error pula. Okay. Kenapa?
Kenapa
Kenapa
dia
tak
guna yang velocity 25?
Okay, tak apalah. Gambar I ni I tak dah nampak dah tak tahu mana. Tapi kenapa kita kena guna velocity 25 is, if you read the question, dia suruh determine the acceleration immediately after the brakes have been applied. Kalau immediately after the brakes have been applied, dia punya speed masih 25 meter per second. Masih 90 kilometer per second. Sebab yang 72 kilometer per hour tu after 8 second. Setelah T equals to 8 second, baru dia jadi 72. So kalau dia nak immediately after the brakes, speed dia masih 25.
Okay. Faham.
Okay. Alright. Okay, good that you ask questions. Good that you want to understand. Good that you're trying a lot of samples. Thank you for those who are asking a lot of questions. However, just give me time to answer. Kalau I a bit late, I will try to answer. But I have received some of your especially from Ikmal Hakim Harun. However, I have some important things that I have to settle this week, maybe in the weekend. Okay, Ikmal Harun? Okay?
Okay, madam. Okay.
Okay. All right. So I will stop the recording and I will put this recording in as usual and YouTube. Okay. Don't forget you have a diagnostic test tomorrow. You can take one whole day to do it. But when you start, you tak boleh stop lah. You understand? Mana stop recording?
Yes.
You know kan apa